Now, at the risk of sounding like I'm beating a dead horse, I want to go one more time through something that you're going to read about all the time when you're looking at any kind of documentation on the design of data warehouses, on the implementation of data warehouses, and that is normalized structure challenges. Because what you're going to find is that a normalized database structure has a few basic characteristics that we can count on. As a matter of fact, that's why we use these databases. First of all, they are designed to store detailed data at the point of generation. In other words, as we sell our widgets or whatever it is that we do, this data gets input into the database. It is designed to store this data as efficiently as possible, as quickly as possible, and with the lowest incidence of row locking and all that sort of thing. It's designed to provide data integrity. We want to make sure that our data maintains its meaning, maintains its relationships. It also results in a lot of tables, individual tables specialized for the data that they store. And the more tables we have, the more efficient we get on inputting data and on managing our data. And it is also a very excellent solution for adding and managing the day-to-day business data that is generated by sales or whatever activity our business is involved in. But it does have a few basic challenges for us that we begin to see over time. It's usually very inefficient for data extraction or for queries. And the simple reason for that is as you get more and more of these tables, every time you do a query to get meaningful data from the table, you have to use these join queries. And join queries can be a little bit challenging to write sometimes, but they are most definitely challenging for the database engine to produce query results because they have to make joins, they have to compare two data sets, return things where they match, where they meet a certain condition that we're asking for in the join statement. And that requires a lot of processing power. Also, a normalized database doesn't store the data in the form that we need for data analysis because really it has the data stored in the most detailed possible form. The day-to-day, account by account, transaction by transaction status. And oftentimes when we're trying to look at sales trends over a quarter, over a year in different regions, different states, different cities, we're not necessarily worried about the most detailed form. And so to get that, we'd have to aggregate. Well, there's no aggregated or pre-summed data or pre-grouped data in our normalized database. And so we have to go through that aggregation process. And that can be quite taxing on the database engine. And there's no discretized data. Everything's out there again in detailed form. It's not broken down by quarters, by all that, those kinds of things. And so that becomes a problem. Then our data may actually be stored not just in one normalized database, but in multiple normalized databases. And now we're doing cross-database queries with permissions and structure and all sorts of challenges. So then we run into this wall that as data storage increases, the efficiency of our queries decrease, simply because there's more data the query has to go through to return our result set. And so we can work with some of this with our clustered indexes and with those sorts of things, but still, generally, the bigger the pile that we have to go through to find our result set, the longer it takes. So the only thing we can do there is to take data out of the database as it ages. Then we find ourselves in a position where the historical data we're trying to get to with our complex, slow-running queries doesn't even exist in the database, and so we can't provide that data anymore. Also, any of those aggregations that we can try to do can create some serious inefficiencies in our data extraction. And it's not unusual. I've had a lot of clients who've told me, man, our queries that want our reports take 15, 20, sometimes 30 minutes to run, and the database just takes a hammering while that's happening. Well, welcome to normalized structure when you're trying to do something with it that it really wasn't designed to do. Now, once you start into all of these things with normalized structures and trying to get your business data or your warehouse type data out of there, your database line of business functions can be impacted and probably will be impacted. And so everybody's trying to input data and it's just getting slower and more painful. And so these are the challenges that the normalized structure is going to give you. Now, I've beat this dead horse quite a bit here, but it's very important to understand and watch for this on the exam. And you want to make sure that normalization doesn't creep back into your data warehouse in the form of these snowflake schemas and that sort of thing. So normalized is great for OLTP. It really presents problems for historical data warehouse type data that we're trying to pull out. So what we're going to do now is we're going to jump into more and more of our star schema, our snowflake schema, granularity, and then we're going to jump into fact tables, dimensions, and then actually start to build a small data warehouse so that you can see how all this comes together.